On this one, we're going to create a polygon, and we're going to have fixed points. We can also do this with points that move around with sliders and such, but we'll start with fixed points here. So we're going to go to the graph and click on Edit Graph. And we're going to be using the Polygon tool. So when you type Polygon, it should turn from italics text to standard text, and we need parentheses. So now we have our rectangle, and we can do a few things with this. Notice that it's red, so that's pretty nice. Maybe we want a black border around it. So we can copy the entire thing that we just created, polygon, and then in a row below it, paste the same thing. Go here, press and hold until you see this screen. Change it to black with no fill. No fill would be zero fill. And you can see that now it has a little black border around it. We could make the infill, the red, darker if you want. So instead of a 0.4, maybe like a 0.7. The fill goes from 0 to 1, so 0.7 is pretty high. I'll change it back to 0.4. We could go to the border, and it has a default of 2.5, so maybe we want to make that really thick and make it like 4. You can play around with that to see what works for you. So this one's done. And now we're going to look at the second one. So we're going to label the vertices of a polygon. So let's say that we want the same exact rectangle that we just built in here for the polygon, and then we'll label its points. So one way to do that is to recreate the same exact thing, but a time saver is in any graph that you've created in Activity Builder, you can go to the bottom over here on the left, and it'll say Edit Graph on Desmos. So you can click that. It'll bring that graph into the Desmos calculator, into their graphing calculator. You can copy the link, click up top, hold Control, and then C to copy. And then you want to paste it in the proper location. For us, it's slide 2 on the graph. First row, I'm going to do paste, which is Control V. And there it is. Now, remember on this one, we wanted to label the vertices. So we can do that a few different ways, but since we already know the points, 0, 0 is a point. Let's label that as A. I just checked the label box and typed A. We can do that for 6, 0 as well. Label B. 6, 2. Label C, and 0, 2, label D. Now you can see that they just auto-populated in different colors, and for me, I would rather make it look nice and clean, so I would probably choose black for each of these labels. To change the label color, you're also changing the point color, so press and hold, and you'll get those boxes to select. And if you would like, although I think I'll leave it this way, but if you would like, you can make it so that the point itself disappears. So watch point A right here at 0, 0. When I click this, it brings the point away, but it also changes where that label is. So if you do something like this and you don't want the point to show up, you may want to change where the label is. Like in this case, it's probably not in the best spot. So you could press and hold and select somewhere on here, like the lower diagonal left seems like a nicer spot to put the A. It does kind of get in the way of that 0 though. So I'm going to show the point. So I'm just going to click back on that, and that one's back. 3 is the X value, and the Y value would be -1. So in here, 3, -1 is my point, and I'll label that. Let's say I label it something that it's not on the graph. Let's say that I label it as 10. If I wanted to change, instead of what I wrote, I'm going to say that it's 10. And that's okay, because if I take away the grid, it just looks like a problem that I created on like a math generator worksheet or something. Maybe I want the 10 to stand out a little bit, so I could press and hold, and maybe I label it as like size 2. It gets pretty large pretty quickly, so you don't have to do a whole lot of fussing. And I'm just going to change point D. I'd like it to be kind of more on the outer diagonal. So I'm going to go to this one, press and hold, and change the location of that one. So that looks nice and clean and neat. I'll hit done. I can preview it. It is a little bit small on the screen, so what you can do is go back into the graph and scroll a little bit, and then go back to preview, and it might be a little bit better for you. I do see that the B and C labels aren't quite where I want them to be, so by sort of playing around with these a little bit, you'll sort of figure out exactly where you want stuff to be and how nitpicky you want to get with it. But that kind of helps out with the standard graphing stuff that you might need to do. You can also set the zoom settings. So if you go to bound, the CL on here, and type bounds and then make bounds, it'll be whatever the X minimum is, and then comma the X maximum, and then the Y minimum, and then the Y maximum. That's how this is set up. So that's just something I'm going to comment out on. And we're going to actually type in the numbers this time for real. So probably -10 to 10 and -10 to 10 is sort of a standard zoom screen for many things. And that doesn't look so great on this one. So what you could do is, if you go into the graph and you show the grid and the numbers to yourself, you can kind of figure out, oh, right, I put it off to the side, a little bit more to the right. So maybe I want a zoom screen of, say, -2 to 8 on the X. And then on the Y, maybe -2 to 4. Keep in mind you can adjust this, of course. So then turning this off again. We can preview it. And maybe that distorts it too much, you know, so you could play around with it a bit. It is something that, so like if I'm looking here, that's from -2 to 8, that's a distance of 10. But over here, -2 to 4 is only a distance of 6. So if I put 2 in each direction, so change that to -4 and change that to +6, that'll be a distance of 10, and it won't distort as much. So sometimes just by zooming in and out, you can easily set it where you want it to be. But then if you go in and change something and accidentally shift the graph, then it shifts in Activity Builder. Whereas if you hit the bounds, make bounds, and set it, then you can shift it all that you want. Like I can throw that off the screen, but when I go here, it looks perfect again. So there's pros and cons to each. It takes a little bit longer with the bounds, make bounds command, but it's also nice and clean and always very consistent. All right, I've got a few quick other things to go through. Graph of functions with restrictions to its domain. So let's pick a linear equation. Y equals 1/2 x minus 5. And let's say that I want to see this graph within an x value of 2 to 8. So I'm going to use curvy brackets. And I'm going to put, let's say, the lowest first, -2, or sorry, I think I said 2, whichever is fine, but because this is just for practice. So we want to write like an inequality statement with X, restricting it on the domain. What was I saying? A true statement with an inequality and X for both sides of the restriction, if we are restricting it on both sides, which for this one we will. Equal to 8. So to get that symbol, you can either use the keyboard down here, the inequality. They have them all four inequalities right here. Or on my keyboard, I'm just using the inequality for, in this case, less than. And then after I've typed that inequality, then I hit the equal sign, and Desmos knows that that means less than or equal to, and it changes it for me. So that's helpful. And take a look at this. So over here on the graph, it's restricted it. So if you need a line, you know, and you want to change where it's restricted, you can make it look a little bit different by doing that. And a lot of the art projects that teachers have students do involve that as well. The last thing is create a movable line for students to drag and drop. We're going to use 2 points for this. Again, we're going to use linear equation just to keep it more basic. So if we're going to have students drag and drop, that means that points cannot be fixed. Like 7, 1 is a fixed point. It does not move from that spot. It always stays there. So think about, you know, if you're telling students to solve a linear equation and to plot points in a table, or to create a table of points and then plot them on a graph, that there are many different locations that it can be in, and it's all based on the X changing makes the Y change. And that's because the X and Y are related to each other through that function. But we don't have to have it that way. We can just say, this is this variable, and this is this variable, and maybe they're connected, and maybe they're not. And so we can say X sub 1 and Y sub 1. Now, when I type that on the keyboard, I'm just typing on my keyboard X, and then immediately followed by a 1, and it automatically subscripts for me. So then I'm going to hit yes to all, and this point can move wherever I want it to go. And I like to make it have a step of like a half, or in this case, I'll do a step of 1. And that makes it so that when I move it around, it's a little bit more choppy, but it allows students to have a little bit more control over exactly where it lands. It's more difficult if it's really fluid. So then we're going to have 2 points, X sub 2 as well. And I'm going to make that one step by 1. And then we're going to write an equation, y equals, now it's mx plus b, right? So we want m, but in this case, how do we find m? Well, remember that m is just the difference in y's over the difference in x's. And our y's are y sub 2 minus y sub 1. X sub 2 minus x sub 1. And so it's y equals m, that piece right there is my m, times x, so times x, plus b. Well, we don't know what b is in the way that I've written it so far. So what we can do is use the point slope formula. So instead of just x, this is going to be x minus, let's use x sub 1, and then we're going to add on y sub 1. And take a look at that. We now have a line that can be moved based on where these points are. And we might want to clean it up a little bit. If we're going to have the line blue, maybe we have both points red. Whoa, don't do that. Hit done, preview. And now students can manipulate the line just by moving the 2 points. All right, that's it.